Yeah, video recording started. All right, so we're officially live. We're live and we're live. All right, so back to the first slide. So today's class is an introduction to Web3. Now, some of you saw the flyer that was done by the community, by those of us that are the admin. When we were promoting the community, saw the flyer. We say we are onboarding people to Web3. So this thing that we're calling Web3, Web3, you'll probably be hearing it. You understand? Today we will not use the term blockchain that much. Today we are going to dwell entirely on Web3. So what is that Web3? Now, I hope you guys can hear me clearly and can see my slide. Can you please confirm? Awesome. All right, so introduction to Web3. Sorry for the typographical error. An evolution of the internet. An evolution of the internet. It's not and, it's an. Sorry for the typo. All right. Now, in order for us to understand what Web3 is, we need to dive deep into the history of the internet, because the Web3 we are talking about is actually an evolution of the internet. An evolution is like the gradual process of something growing to become better and better and better and better. It's changing form, it's changing shape, it's changing behavior. You understand? It's changed psychologically, it is also changing. The way it interacts with environment is changing. So that is evolution. So the internet is a system that does what? That is in continuous cycles. You understand? It continues to develop itself. People develop it and it develops itself. So let's discuss the history of the internet, because the Web3 we are talking about is actually on the internet. Let's go. Now, let's go a little bit technical. The history of the internet. Now, in 1989, at CERN, how many of us have heard about particle acceleration? Or how many of us know the organization that is called CERN? Those of us that are science students. Anybody here knows the organization that is called CERN?
No.
Okay. All right. If you're a science student, you're supposed to know who CERN is, right? By now, in 2024, you're a science student, not your science student. Everybody on the planet should know what CERN does. The same way we all know what NASA is. We all know NASA. Aerospace missions, right? Go to space, International Space Station. Now everybody should know who, what, now what organization, what CERN, what they do. Now CERN is located in Geneva, right? United States of America. So in 1989, at CERN, which is an organization, they do particle acceleration, which is physics, spark particles, protons, neutrons, trying to know the in-depth atom of different materials and all of that. So in Geneva at CERN, Tim Berners-Lee was busy developing protocols that would become the World Wide Web. The World Wide Web is a different topic of its own, but what the World Wide Web is a set of protocols, is a set of tools that makes it possible for us to view content on the internet. You understand? The set of protocols that helps us to view content on the internet. When you tap a link, take for example, you are in a web page, and even if you search Google, you see search results, right? When you click on the link and it takes you to the web page, what makes that possible is the World Wide Web, right? The World Wide Web is different from the internet. The internet is the internal infrastructure, while the World Wide Web is the protocol built on top of the internet to make content sharing. Understand? To make the internet interactive, make us move from one link to another, make us view content on the internet, watch videos, stream music. You understand? These are protocols that are built, these are tools that are built on top of the internet. That's the World Wide Web. This is not a web development class, so I will not go deep. So his idea is to create is to create open and decentralized protocols that allowed information sharing from anywhere in the world. Now, the idea of Tim Berners-Lee actually starting the internet, when he had the idea, was to create an open and decentralized protocols. You understand? Open and decentralized. Meaning that we'll be talking about decentralization since the beginning of this class. Class 1, class 2, class 3. This is our fourth class, and we're hearing the word decentralized again. You understand? We all know that the blockchain is what made decentralization possible from our last class. Now, you can see that the original plan, the internet today is not decentralized, right? But you can see that the original plan of the person that invented the internet was for it to be decentralized, because he knew the consequences of centralization. You understand? Which we are facing today. You understand? And these systems will further allow sharing of information sharing from anywhere in the world. So anywhere in the world, you can share information to anybody. When we say information is also data, it's messages, it's content, it's anything. You understand? Information is just basically data that is sent across the internet, you understand, in an understandable form. It can be text, can be video, audio. All these are information sharing from anywhere in the world. No location barrier, as long as you have access to the internet. Understand? So as long as you have an ISP, and an ISP can, give you, different data packets, basically from different nodes on the internet, wherever you are, you make your request to, and you are getting a response from. I'm actually talking deep now, but I'll try to, stay above the water so that we can all float. Now, Tim Berners-Lee, for those of us that are some of us are technical here, Tim Berners-Lee used Objective-C language to develop the first web server on a Nest computer. Now, in case everybody here is supposed to know what Nest computer is, though, you understand? But for those that don't know what Nest computer is, the Apple computer, which we are hearing of today, the Mac OS, that's the MacBook, the Air Max and the Mac Air, PCs that we're seeing today, the laptops that we're seeing today, they were built by Apple computer. Now, in the 90s, there was a problem at Apple. So Steve Jobs, which was the original CEO of Apple, left Apple to go and build another company. And that company was also a computer company, and that is the Nest computer. You understand? So it's still around, Apple kind of story. You understand? I'm a computer science student. That's why I know this. It's privileged information. Now, Tim Berners-Lee used Objective-C to develop the first web server. I won't explain what a web server is, though. But in the concept of Web3, a web server is like a node. You understand? It's like a node on a blockchain. You understand? In the case of Web2, a web server is just like a computer that is holding files that people need to access. You understand? Like a web host. I won't go deep so that we can stay afloat. Now, the name of this web server was called HTTPD, which ran in the background as a daemon. In computer science, there's something called a daemon. A daemon is an app that runs on the background. You don't see it. You cannot see it. You cannot trace it. It's just in the background. Understand? And this daemon served web pages to the web browser. For technical people here, you can see how the internet started. These slides will be made available, and this video will be made available. You can go and do more research on it. Don't ask questions yet. At the end of the class, you can ask your questions. If you have any questions now, you can just type it on the group or have it on your phone or write it down. I expect most of us in this class to actually have notebooks. As I'm speaking, something resonates with you, you write it down. All right, let's continue. He also developed Tim Berners-Lee, which is the person that invented the whole internet, you understand, the World Wide Web, developed the first web server, also invented the first web browser and made it open source. Making the first web browser open source means that he made the code available. So you can change, if you don't like the way the web browser is, you can make modifications to it to make it better, to suit your own taste and use it for yourself. That's the whole concept of open source. Next slide. Now, here are some facts about the internet. Now, Before I go into these facts, I will explain something. The internet is actually a distributed system, right? The internet is actually a distributed system, meaning that the internet is not inside one single computer belonging to one organization. You understand? But the internet is actually spread across different computers. So the internet is actually decentralized. But how come we are saying that the internet that is decentralized is actually centralized? It's because the people that have these computers, that these distributed computers spread all over the globe that make the internet decentralized, they are all connived together. They've all hold meeting in single rooms and decide that the data that we put on the internet, you understand, is their own. They own it and they can do whatever they want to do with it. You understand? They can censor it and they can, like, they are all working together. You understand? They are just like an army of people that have come together in agreement. They share the data within themselves, but the data does not belong to us. We don't have access to that data. You understand? Though we give the data to them, but we don't have access to it. We can't even take it away from them. They can only make a photocopy of it and give it to us. They still have the data. So they still, anything you do on the internet is being stored on a data center, right? Right across the group on different data centers, and that data does not belong to you. You will understand why it does not belong to you in this particular class. Now let's look at some facts about the internet. The first fact about the internet is that it was originally designed to be decentralized using the principles of distributed computing. The internet is run on nodes. You understand? Computers spread across the group, connecting together to form a network. That's the global network of interconnected computers. That's actually the internet. You understand? It was originally designed to be decentralized, but just that the people that have these nodes, the people that have most of these nodes, have connived together to separate us from our own data so that only them can profit from it. You understand? It's called the data war. There are books written about the data war. I would recommend you get a book on data war. You understand? Surveillance capitalism, books like that. So we'll talk about all of those. Second fact, the first internet browser was open source, allowing individuals to review its code for versatility, usability, authenticity, and future development. Like I said, the first web browser was open source. Everybody have access to the code. So you were allowed to do whatever you want with it. Understand? That actually makes sense. The concept of open source is a bit above the level of this class, so I will just stick with what we have here. The third thing, ever since the internet started, it has never shut down globally or worldwide, meaning that there has never been a point since the internet started where the entire internet in the entire planet shut down. There have been cases whereby 46 countries at once, their internet was not working. There have been cases where 34 countries, the internet is not working, but the entire world internet has never shut down at any given time. The global internet has always been functioning, right? However, there have been attempts by governments to shut down the internet in their respective countries, such as in Egypt in 2011. The Egyptian government shut down the internet in their countries. They were trying to stop a protest in their country. Same thing for South Sudan. In 2019, South Sudan they shut down the internet to stop protesters from, sharing information. You understand? There's also a conspiracy that the one of South Sudan was actually an attack on the country, but there is mixed opinion on what exactly happened. Now, I think let me save that for later. But just understand that sometimes the government can try to shut down the internet, and that's a bad thing. If your business is on the internet and you depend on your business to feed, if the government shut down the internet, it means there is no food for you. First of all, our bank accounts are in the internet. So if the internet is shut down, what do you think happens? You can't transfer money, you can't buy or sell. That's what it means. So we need to develop things that can manage this risk. We need to build tools, infrastructural tools that can manage these risks. These are risks, and we need to manage them by building, tools that will enable us solve these problems. These are not good things at all. Shutting down the internet is not a good thing for whatsoever reason. It's not a good thing. Understand? People can die because the internet went down. I'm telling you, your cash, your money, everything is inside the internet. If the internet goes down, that's it. That's it, man. But you will see where Web3 comes in all of this as we proceed. Now, some key points. Some key points. Innovation on the infrastructure of the internet has not been completed. Now, this is a very, very important point. Now, some of us think that the internet has finished developing. There's no need, there's nothing for me to do. But the truth is, there are problems on the internet that needs to be solved. There are problems. The internet needs you to survive, to keep progressing. The internet needs me and you to keep progressing. So there is need for me and you to actually come together to solve some of the problems that the internet of today has. Some of these problems, and some of these innovation that we need on the current state of the internet are connectivity, 5G and 6G. Whether you like it or not, we need 5G, we need 6G. The internet needs to be faster. The internet we have today is still too slow for some certain things. Take, for example, they are trying to make it possible for a doctor in the US to operate a patient here in Nigeria right from their home. With the current speed of the internet we have today, we can't do that. If you are a science student here, you are a tech student, in fact, wherever you are in art, whatever you do, know that the internet has problems that needs to be fixed. One of them is connectivity issue. We need speed. Understand? Second one is artificial intelligence. We need to add more artificial intelligence to the internet to make it smarter, to make it more useful. You understand? The third one is security protocols. The internet we use today has very big security loopholes. People's accounts are still vulnerable to hacking. You understand? Thank God for blockchain today. Thank God for a blockchain such as Bitcoin, which is unhackable. I think Bitcoin is the only thing I think is unhackable right now on this planet. Almost everything is hackable except Bitcoin. Bitcoin is not hackable because of its hashing algorithms. We'll talk about Bitcoin in some of our advanced classes, right? So we need security protocols to even protect down to our messages we send on WhatsApp so that hackers don't intercept them. Take, for example, if they are sending you OTP for you, that let's say you are making an online transaction and you are receiving an OTP. If a hacker intercepts that OTP and first you to authorize this transaction, the hacker can actually modify the details of the transaction and actually get your money, get into your account. So a lot of things can happen if you are logging into a social media application, not knowing that a particular there is an app on your phone that is not good, that is malicious, that is reading everything you are doing on your screen. It's actually reading it, and that app was able. And the programmers of the app, which are the hackers, were able to intercept that OTP message. Can you guys hear me? Did my network go off just now?
Yeah, it went off. Now it's back.
It's actually shaking.
Just go ahead.
It's shaking, please.
Okay, all right. So we need better. I can hear you. Is anybody asking questions?
I don't think there is anybody that's asking questions. Just like your network is shaking, and you talk is very interesting.
All right. I think you know what. You guys should just give me a minute. Just give me a minute. Let me do something that will improve this network. I don't want to have this issue again.
All right, that's one of the problems internet is having.
All right, so I'm back. We should not have any network issue now. Oh my God, is this reloading? Interesting. All right, so back to business. So we need advanced security protocols on the internet that are completely unbreakable, that are not penetratable. Understand? We need better data encryption, right? We also need to develop quantum computing, you understand, so that the internet can, progress into the next phase, which is Web 4.0. But we're not going to talk about that in this class. Simulation, right? If you want to do your own research, you can do your own research after this class, how we can add quantum computing into the cloud and also in the internet generally. Quantum computing itself can improve encryption algorithms by helping us develop algorithms that cannot be brute forced, cannot be broken by quantum computers. Internet of Things, which is basically our devices, our household gadgets, you understand, communicating with each other, right? We need to find a way to secure those kind of communication. If a hacker can control your cooking, stuffs, if they can hack items in your house that are used for cooking, for cleaning, and all of that, that's bad. We need to secure We need secure communication tools and protocols for Internet of Things. Also, we need efficient storage technologies, right? We need to start storing, data in petabytes, in zettabytes. You understand? We need to develop that for the internet as well, so that data centers can be less bulky. Today, you see, a building as big as this entire University of Utrecht as a data center can be reduced to even one bedroom flat. Understand, with better efficient storage technologies. Server architecture, right? The way we send requests to the servers and receive, the speed at which we receive, and the kind of request, and what we can actually do and what we cannot do. And we need to create new possibilities in the server architecture. Find better ways to make responses faster. Understand, minimize the size of messages that are sent between the server and the client. You understand? Satellite internet can solve the problem of the internet and actually shutting down, right? Elon Musk is already working on that. That's Starlink. Starlink is independent of internet service providers. It works directly with satellite. You understand? So you too can come up with a solution like that. If there is competition in the market, if more than one person is doing this particular thing, the cost of the product will reduce. As if there's the monopoly in the market, that company that has the product will continuously increase the price because no one else is offering that service. So, but if we have competition, there will be a price drop because of competition. Right? We need privacy tools, right? We need social media platforms that are completely private, right? Take for examples, most of you don't know, but our government, they have backdoor to our social media chats, right? Apart from the Telegram that is on telegram.org, all the other social media platforms are completely, the government can see your messages if they want to. If they want to, do research about you, let's say they have an investigation they want to do. They can read all your WhatsApp messages, all your Facebook messages without your permission. They don't need to log into your account, right? That is part of the problem of centralization. Social media platforms these days are not private at all. They can sell your data to the highest bidder, right? Your data can be sold to the highest bidder. Somebody can pay Facebook to get your data, in case you are not aware. Understand? And a hacker also can also hack Facebook and get your data. You get? So these are problems that we need to solve, right? So these are problems with the current internet that we use today that you can solve. You can build businesses around these problems and make the internet better. This slide is actually important, and I think it deserves the time that I gave to it. Now let's move forward. Now let's discuss how the internet started. Now the internet started from what is called the Web 1. the Web 1, the first version of the internet. The Web 1.0 or Web 1, Web 1.0 or Web 1, they are the same thing, is the first version of the internet. And it is called Web 1.0, like I said. Users on the internet, from when it was open to the public in 1989 till 2000s, were only allowed to read information from the internet. Now, if you started using the internet from from the 1990s, you understand that the websites that were available by that time, there was no ability, there was no interaction. It was only read only. It was like a newspaper, right? It was purely like a newspaper. When you visit the website, all you do is to just see the information. There was no interactivity. There was no interactivity at all. You can't add comments. You can't ask questions. Nothing. You just read only. We are only allowed to read information from the internet. Now, Web 1.0 refers approximately to the first decade of the internet. That's the first 10 years of the internet. Information was only read from different nodes on the internet by users. Websites were static. Websites were known, they didn't have moving objects. It was just pure words. You understand? Pure words and images as well, though. And there was no other form of interaction aside scrolling and reading. You get the point now. Apart from scrolling and reading, there was no other form of interaction on those websites. Now, so this is the diagrammatic representation of Web 1.0. As you can see, we have two computers, you understand, and we have another computer. This computer that we have in the middle is called the server or the node. Server and node are the same thing. You understand? Server and node are the same thing. This is the server. And what people do is that they read information with their computers. You understand? There were no smartphones then. You understand? They read information from these computers. You understand? You send a request to the. And there was no. Yes, you send a request to the server. You send it because we're using the World Wide Web. So you send a request to the server. You get information back, and that was it. There was no interaction. In-depth information you get back, just read only. Two computers reading information from the server. Now, the tech stack. Now, it's very important that I share the tech stack. What was used in developing there was no applications then, right? Applications were not in Web 1.0. What was the tools that were used to build the website of Web 1.0? Basically, from 1990 to 2004, basically. That's how we denote it. But the internet started from 1989, basically. Operation started from 1989. Now, the tech stack is basically, these are the tools and technology that were used to create websites during that era of Web 1.0. Note that there were no web apps available in this period. There were no web apps because there was no interaction. Web applications are interactive. They have databases. They have buttons you can press and all of that. During this time, there was nothing like that. You can move from one page to another. You understand? Let's say you are on a web page. There could be a link to another web page whereby you click on it, it takes you to the next page. But that's just visiting another web page. That's not main interactivity. The only tech stack that was used in making Web 1.0, sorry for the typo here, 1.0 website was just HTML. Understand? It was just HTML. During the last part of this era, HTML technology have already reached 3.2. So HTML 3.2 was what was used to build the websites of Web 1.0, that era. Let's move on. Examples of Web 1.0 websites. Examples of Web 1.0 websites. These are static sites. There's no interactivities. Users have no ability to add content to these websites. The content was read only after it is published by the owners of these websites. Example is Britannica Online all personal website, news and blogs with no comment and search functionalities, mp3.com, ofoto.com, etc. Right? These are examples of Web 1.0 website. Basically, you just see the content, you read it, and that's it. You can't do anything else. Let's continue. Now, what are the issues of Web 1.0? Static HTML pages, limited interactivity, no animations, no user-generated content, no social media integration, no streaming of videos, and very basic search functionality. The search functionality was very, very basic. It was just like inside search. Basically, you are searching with just the web browser and not happening in the back end. You understand? It's not happening in the back end because users were not allowed to send information to the back end. You understand? Search functionality was just within the web browser. It was not back end based. Now, Web 2.0, which is the current internet that we use today. Now, the Web 2.0 period began in 2004 with the emergence of social media platforms. Instead of read-only, the web evolved to read and write. Instead of companies providing content to users began to create content on different platforms to share user-generated content and engage in user-to-user interactions. Now, user-to-user interactions that's our comment. Somebody posts, we comment. That's user-to-user interaction. We like, we share, user-to-user interactions. You get the internet, starting from 2004, the internet was no longer read-only. Social media, this kind of social media platform stuff has already started with the emergence of platforms like Facebook. Right, so instead of companies providing us the content that we watch, users started creating their own content and publishing it on these platforms that came up like Facebook. Now, this is the diagrammatic representation of Web 2.0, right? This is the diagrammatic representation. You can see that we have a central computer, which is the server or the node, and we have two other computers that are sending and receiving content. Instead of receiving only content, they can both send content, they can both add content to this website and also receive content. I believe we all understand it. In fact, if you've been following from the first class, second class, third class, this should not be hard. There's nothing here that should be hard for you at all. Very simple to understand. Let's continue. The possibilities of Web 2.0. The internet has become a very useful tool since its evolution into the 2.0 stage. Some of these possibilities are social media integration, user-generated content. Now we have social media platforms. We can comment, we can, share, do whatever we want, stream videos and all of that. Dynamic pages with HTML5, CSS3, and JavaScript. If you're a technical person, HTML5 came with a lot of good features, such as filling forms on the internet and submitting forms. CSS3 came with animations and all of that. Application of the internet. JavaScript came with interactivity, a little bit of animation as well, with buttons, pop-ups, and all of that. And also, Web 2.0 ushered us into the realm of web animations. Understand, web animation and effects on different websites and web applications. Responsive and mobile-friendly design started, from Web 2.0. Basically, you can use the web on your smartphone. Video streaming, Web 2.0 made it possible. The tech stack for Web 2.0. The tech stack for Web 2.0. Basically, these are the tools and technologies that we use in creating websites and web apps during the Web 2.0 era, not Web 1.0. Sorry for the typo. The tech stack that is being used in making websites and web apps. Now, if you notice, I added web apps to Web 2.0. because this is the era where we had apps, web app. Basically, these are applications that run on the website. Once you have buttons, you are seeing pop-ups. We have a database. Basically, we are storing information somewhere and we can retrieve it. People have profiles. People can comment, like, and share. That is already a web application. Websites are just websites. They are static. A website is actually a static. Take for example, a landing page with no interactivity at all. It's just a website. But once we start clicking buttons, we start seeing pop-ups, that is a web application. So that's the difference between a website and a web application. This is not a web development class, so I will just keep it as simple as that. Now, HTML5 is one of the tools that we use in developing. You understand? We've talked about that before. CSS3, this is the tech stack, JavaScript, PHP, and Python being used in the web, databases, relational and non-relational databases, APIs, which application programming interfaces, cloud computing, and content management platforms, etc., etc., etc. So this is the tech stack, content management platforms like WordPress, basically. Understand? That's CMS. So these are the tech stack for Web 2.0. I believe it's understandable. You can do a little bit of research on this slide. These slides will make available as well. This video will be made available as well. Let's continue. Now, examples of Web 2.0 websites. Number one is Facebook. Number two is X, which is now Twitter. Instagram, LinkedIn, YouTube, GitHub, Spotify, Google Docs, and Minecraft. These are examples of Web 2.0 websites. Very popular websites. We all know them and use them. Some of us, we use some of these websites every day, right? Let's continue. The issues with Web 2.0. Seems as if this stuff is too upwards. Wow. So what are the issues with Web 2.0? What are the issues with Web 2.0, which is the current internet we use today? Now let's dive into the issues. As more people came online, as we have more people coming online, today we have close to 4 billion. No. We have more than 4 billion people online. We have close to 6 billion people online, I think, or even if not more than, right? We have more than 6 billion people online on the internet as of 2024, I believe so. Now, as more people came online, as more people are coming online, a handful of top companies began to control a disproportionate amount of the traffic and value generated on the internet. Like I said, these guys came together, connived, had a meeting, and they said the data we share on the internet belongs to them. If you read the policies of Facebook and some of these platforms, that's when you find out. Some of us have never read the privacy policy, terms and conditions, blah 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 of this website, so we don't know. But actually, the content we post on the platforms belong to them. That's why if you post a content they don't like, they can delete it by themselves, and you can't sue them because they own the content. How did they make sure that they own the content? They own the content by simply, before, when you are registering for the website or the web application, social media network, whatever you're trying to register for, they told you to read those policies, and they told you there that whatever content you post is their own. And if you don't like it, it's better you don't register, but you choose to register. So basically, you've already sold the content to them by ticking, I've read the terms and conditions. Yes, agreed. We don't read. So you sold the data to them by checking that box, basically. You understand? So Web 2.0 also bettered the advertising-driven revenue model. Yeah, we see ads on the internet today. That's the advertising-driven revenue model on the internet. Funny enough, these platforms that are social media platforms or internet apps that we use today that have ads in them, they don't split the revenue with their users. They are making a lot of money and they are pocketing it for themselves, right? And that's the problem, because without us, there will be no ads. If everybody leaves Facebook today, Facebook is done and Facebook is doomed, right? There will be nobody for Facebook to sell ads to because there are no users. No users, no ads. You understand? So that's basically it. While users could create content, they don't own it. They don't own the content they create or benefit from its monetization. The monetization of content is basically the ads that we watch on the platform. These social media platforms are monetizing our content, but they are not giving us the money. Right. User data was extremely centralized and privacy violation became rampant. User data being extremely centralized means that all your data on Facebook are just with Facebook, and privacy violation means that Facebook can share your data with the government. They can give the government backdoor to your chats and basically read whatever they want to read and find out whatever they want to find out. The issues with Web 2.0 are basically centralization, content ownership, security, monopoly and control, and censorship. Censorship is you post the truth and Facebook deletes the post about the truth that you spoke. Or because of what you post, the Nigerian government automatically stops you from transferring money from your bank account. So these are censorship mechanisms. Or you post something, and because you post something, your engagement on social media platform automatically reduces. This because you said something. So even freedom fighters can't use social media of today, because if they try it, they will censor them, and maybe their post used to get 100,000 views before. The post will reduce to 50 views. Right? That's censorship, right? What is making censorship possible is monopoly and control. You get it? And these platforms are not 100% secured because they don't have some of the most recent protocols and tools, such as even the blockchain, for security. People that are sophisticated can come together, hack Facebook for your data, right? So content ownership, basically we've talked about that. The content you post on Facebook is not your own. In fact, you agree to sell it to them when you're registering for your account. You sold the content to them yourself by ticking I agree to the terms and conditions. Right, let's move on. Key takeaways. The evolution of the internet happened in tandem with other forms of technologies, such as the launch of the smartphone. So the invention of the smartphone also affected the development of the internet. You understand? The breakthrough of wireless communication also affected the development of the internet. The innovation in the field of web browsers on their own have history. You understand? They evolved into what we use today. The invention of JavaScript, changed the entire internet for interactivity and etc. etc. A lot of things contributed to the evolution of the internet. You understand? So I just wanted to point that out for us to, quickly, get a grasp on that. Let's move on. Now we've come to the key word of today. The reason why we are here today. What is Web3? What is Web3? Now, the term was first coined in 2014. Now, speaking of the person that coined the term Web3, the person was the co-founder of Ethereum. It's not included in these slides. That will even be one of our quiz questions. So you can write that down. The person that coined the word Web3, his name is Gavin Wood. I will type it in the community after this class. That should just be our little secret for those that attended. So Gavin Wood is the co-founder of Ethereum. Gavin Wood, he was the person that coined the word Web 3.0. It's a cash term for the third iteration of the internet, of the World Wide Web. Third iteration of the World Wide Web. This version of the internet is poised to be a good and better version where individuals can read, write, and own their data and assets on the internet. What we are protesting for with Web 3.0, because this is a protest, because we are basically singing it. Take, for example, me hosting a class to teach people about Web3. I'm preaching the gospel because I want people to adopt Web 3.0 because it is actually going to benefit me. It's going to benefit you. It's going to benefit our children and their children and their children. The internet needs to evolve. Some of these demoralistic things that are happening on the internet today needs to stop. So this is me protesting. I'm preaching the gospel of Web3. that we need to adopt Web3, we need to stop the monopoly, the censorship, the centralization, and all of that. We need to stop it and move the internet forward. Right? So people need to, read, write, and own their data. They need to own their data. Right? So I want to own my content on the internet, and I decide what to do with it. Not social media platforms decide what they do with my content, and they even tell us what we can post on and what we cannot post. You understand? So basically that's it. This is the diagrammatic representation of Web 3.0, right? In Web 3.0, there is no central server. You understand? There is no node. Like, there are basically nodes. I will explain how the nodes function. But these nodes are running a particular blockchain. You understand? This node, it does not concern them what we do with our data, with what we share on the internet. It is not their business. Their business is just to make sure that the blockchain runs smoothly and efficiently. You understand? So there is no third party, there's no centralization. It's a complete peer-to-peer system. I've explained the concept of peer-to-peer network in our previous classes. If you missed those classes, I'm really sorry. We've talked about peer-to-peer decentralization and how peer-to-peer systems work, whereby two people can communicate without a central person. There's nobody in between them. I can send you money without a bank. That's just it. The money gets to you without a third party. There's no bank. Right. I can send you a message straight to you without it passing through any central authority, right? Any central node, any central computer or server. So this is the concept of Web 3.0 is building what trustless and permissionless protocols. Right. So the possibility Can you guys hear me? Something stopped my network.
Yeah, just now something stopped it. But now we can hear you. I can hear you.
Just
That
came.
that is Telegram actually. It's not my network. I just discovered the fault is not from me.
What
Telegram
happened?
do experience. It's not my
Alright,
network.
can you hear me now?
What happened just now is not my network actually. My network is fine. I just discovered my network is fine. It's just Telegram. Telegram does this sometimes.
Yeah, all right.
Okay, so our video is still recording. All right, so where did I stop with you guys? What was the last thing I said? Was it here?
Yeah, it was here. It was Web3. Yes, we're talking about Web3 now.
Okay. All right.
We're talking about owning our content and the rest of them.
Oh, I see. All right, so did you guys hear what I said about peer-to-peer systems?
No, that was when the network.
Yeah.
I think there was bridges.
Okay. Sorry about what happened, but it's not me that did it, and it's not my network. It's Telegram. As Telegram can be overloaded, and things like this can happen. Right? The owners of Telegram need to they need to add more computers to their server so that we can have a smooth time on Telegram. All right. So, like as I was saying, in Web 3.0, the entire concept is to eliminate a third party, is to build trustless and permissionless protocols, whereby we don't need to trust an entity such as a bank or a social media giant like Facebook to host our content. We can share our content with each other without a central authority. So it's a complete peer-to-peer system, you understand, that is built on a trustless and permissionless protocol such as the blockchain. And what the blockchain does is to keep you understand, is to keep our content in such a way that the content cannot be taken away. Content on a blockchain is immutable. From what we say in our last class, we established the basis of immutability, that the content on the blockchain cannot be changed, cannot be deleted. It is permanent. It is permanent, you understand? And the blockchain can actually not be broken. In order for you to hack the blockchains, you have to basically stop all the decentralized, all the computers that are actually running the blockchain across the world. You have to go and off them, turn them down for you to, or DDoS them, you understand? Basically DOS them. That's we'll explain the concept of DDoS in other classes, one after the other. And these are millions of computers that are keeping the copy of the blockchain. They are millions. They are basically millions. It's impossible to do. It's like trying to shut down the Bitcoin network. There are governments that have actually planned to do that, but they saw that it's impossible. Because even if you shut it down in the US, in North America, what about here in Africa? It's impossible. It's everywhere. Bitcoin mining is happening everywhere. Everybody has a copy of the blockchain. It's impossible to shut down. So that's what we're trying to build with Web3. We're trying to build a peer-to-peer system with no central authority. And once we eliminate the central authority, there will be no censorship. There will be no control by a central authority. There will be no monopoly. And that is where we can start building privacy, privacy-based tools, protocols, and platforms. Platforms that are completely private. The government cannot even infiltrate them. Now, the possibilities of Web 3.0, not Web 2.0, sorry. The Web 3.0 internet aims to be trustless and permissionless. It aims to be trustless and permissionless. There's no central authority, and you don't need to take permission from anybody to do anything. You own your content, you own your assets. All user-generated content are owned by users. The communication is peer-to-peer. The platform is truly decentralized because basically anybody can run a node. We talked about the concept of running nodes, you understand, but we've not discussed how to join a blockchain network. That will be happening in one of our future classes. The platforms are censorship-free and they are unhackable. It's impossible to hack. It's fully private. Users can choose what data to share with platforms. It's fully private. Unlike Facebook, when you are registering, they ask you for your name, your first name and last name, your date of birth, and if you don't provide this information, you can't even join the platforms. And if you lie, if they discover, they can take down your account and tell you that the information that you are sharing is false. Or they can actually lie that something is wrong with your account and ask you to provide the true information, such as with documents such as your proof of identity card, to prove that the information that you provide to them is true. So all these things they're getting so much data from their users. But in Web 3.0 platforms, all those kind of information can be kept private because Facebook can be hacked. And what if somebody gets all your information about you and goes to your bank and pretends to be you and take away your money? So all these things are risks that we need to eliminate. Decentralized finance that does not involve a central authority, that does not involve a bank. We can lend and borrow money without banks, without a central authority. Basically, there is trustless and permissionless. We just have to work with a smart contract. In one of our past classes, we established the basis for smart contracts. Now, smart contracts and decentralized finance is going to be a future topic that we're going to discuss again. How smart contracts work, deep dive, and decentralized finance together in one class. So watch out for that class. We'll dive deep into DeFi. Now, the Web3 tech stack. What is needed to build Web3? Web3 apps, Web3 web apps and protocols. Websites and applications built with the Web3 tech stack are called decentralized applications. I will read that again. The websites and applications that are built with Web3 tech stack are called decentralized applications. The web apps that are Web3 based are called decentralized applications. They're basically called dApps. So when you hear the word a DApp, decentralized application, it's actually a web application and a website that is built with Web3 tech stack, that is built for Web3. Now, the tech stack of Web3 Web 3.0 is most of the Web2 tech stacks. We'll talk about JavaScript, HTML5, CSS3 and all of that, animations, video streaming, all those things. You understand? All those tech stacks that are also in Web3 tech stack, except for database. So in Web 3.0, instead of us using a database, a relational and non-relational database, we are using the blockchain as our database. So we don't have database that is centralized. We have completely get rid of centralization and we are working with blockchains instead of databases. So everything in Web 2.0 tech stack except databases. Number 2, data APIs. Number 3, Web3.js. I won't be going deep. This is a JavaScript framework, right? The blockchain-specific tools such as Solidity. Solidity is a language that you can use to write decentralized applications for platforms like Ethereum. Or I think Solidity is also compatible with other EVM, Ethereum virtual machine-based blockchains. We'll talk about all those in more advanced classes. Wallet Connect, understand, is part of the tech stacks. Basically, it helps people connect wallets to your decentralized applications. MetaMask is actually a wallet application that users can use to, launch your decentralized application and then connect their wallet. There's Truffle, there's Ethers.js, there's a Remix IDE, etc., etc. Now, these are examples of websites that are Web 3.0 based websites. Number 1 is OpenSea. Number 2, Uniswap. We have Aave, Compound, Steemit, Mastodon, Jupiter. Mastodon is a social media, Web3 social media network. Steemit is a Web3 social media network. Compound is a decentralized finance application. Aave, the same thing. Uniswap is both a decentralized exchange and is also involved in DeFi as well. OpenSea is an NFT platform, non-fungible token platform where you can buy. Is a marketplace for non-fungible tokens, right? Jupiter is a decentralized exchange. Magic Eden is a NFT marketplace. DYDX is a PEP platform, a platform where you can trade PEPs, perpetual contracts on decentralized network. We have Carbon browser, which is a decentralized web browser. Basically, it is a DApp. It's a web browser that is meant for Web3. We have Storage, which is meant for data storage in Web3. Polymarket. I think Polymarket is for betting, right? Yeah, it's for betting. Zeta Market. You can sell almost anything on the Zeta ecosystem in Zeta Market. StoneFi is basically another DApp that is a decentralized exchange as well. Variable, NFT marketplace, Blue NFT marketplace, Ondo Finance reward asset, Pendo Finance reward asset, TokenFi reward asset. We'll talk about all these things. Now, other key takeaways. We'll talk about all these decentralized platforms in some of our advanced classes. But I just want you to get used to the names and also have them, right? You can do a quick Google search on them and try to know what they mean and what they do, right? Here are some other key takeaways. The problem of Web 1.0 was the technical problems. The problem we had with Web 1.0 was technical problems. The problems we have with Web 2.0 are moral and ethical problems. And the problem we have with Web 3.0 is adoption. We don't have people using Web 3.0. That's the problem we have with Web 3.0. In Web 1.0, we needed the internet to have interactivity. We needed the internet to be more interactive. We wanted people to be able to comment, and post content on the internet. We solved that problem, but when we solved the problem, we had moral and ethical issues whereby people are not allowed to hold the content that they post. They can't even monetize it. Monetization is such a big deal right now on platforms such as social media. You understand? Your data is completely owned by platforms like Google. You understand? By Facebook and the rest, etc., etc. That's Meta, right? So those are moral and ethical issues. Censorship, you understand, that's a moral and ethical issues. If a political official does something such as the president of a nation, if you go online and you critique it, you can take down your post or even ban your account or shut down your account because of what you say. That's censorship. You understand? Stopping you from using your account. That's your bank account because of what you said online. That's censorship. Or because you did something, they'll officially flag your account and deduct money from your account. All those are censorship. And the problem with 3.0 is just adoption. Adoption, right? Now, how can I get involved in Web 3.0? I believe, is this not our last slide? Okay, this is the last slide. How do you get involved in Web 3.0? This is where we're going to be ending today's class. What are the steps in getting involved in Web 3.0? Number one, get a wallet. You need a wallet. Your wallet in Web3 is like your email address, although we'll treat wallet separately in our future classes. Your wallet address is like your email address. In fact, your wallet address is your email address. When you are registering for a platform such as any platform at all, they ask you for your email, right? They ask you for your personal details, you enter a password, right? So your email and password in Web3 is your wallet. Yeah, your wallet is what you use to sign transactions, is what you use to interact with decentralized applications. Without your wallet, you don't have a profile, you don't have an account on any of these platforms. Your wallet is what gives you your account. So your wallet is actually your email in Web3. Take note of that. Step 2, find a community. Now you are in a community that is teaching you about Web 3.0. Thank God for somebody like me that volunteered and decided to teach you for free. So start having a wallet. The next thing you actually have to do is to find a community to join, because Web3 is what is an place. You understand? The platforms are not fully formed yet. You need to be part of the community to learn how these platforms work. Understand from other people's experience and also share your experience. Number 3, explore Web3 applications, right? You need to test different Web3 applications. Don't worry, you'll be taught how to test Web3 applications, how to learn about them, how to explore them, how to know about which ones can meet your needs and what you need to do and all of that. Understand? Right now, you are in the right place. You are in a community, right? So some of us don't have wallets yet, but you are in a community, so that's a good start. You'll be taught how to use Web3 applications in future classes. Number 4, join a DAO. Now, they will have a separate class on DAOs. DAOs are called decentralized autonomous organizations. We'll have a separate class for them. These are organizations whereby decision making is decentralized. It's about voting, right? If you join the DAO, when it's time to make a decision, right, a vote, like a poll, will be posted into the blockchain, right? And people have to vote. Whichever part wins the vote, the law gets passed. It's like the DAOs are like the Senate, House of Rep and House of Senate. You understand? When we want to do something, we want to embark on a mission, we want to build something, we pass a bill, and when we pass the bill with the highest vote, you understand? If we vote against the bill, the bill will not pass. If we vote for the bill will pass. So that's basically the work of DAO. We'll dive deep into DAOs. Then number 5, which is the last way to get involved in Web3, is build on Web3. Build your business in Web3. Build your products in Web3. Build your projects in Web3. You understand? So build on Web3. That's how to get involved. First one is to get a wallet. Number 2, join a community. Find a community and join a community. Be active. Be active. Join a community and be active. Number 3, explore Web3 applications. Number 4, join a DAO. Number 5, build on Web3. Build your products, your app ideas, bring them all to Web3. So that's how you get involved. Ladies and gentlemen, that is the end of today's masterclass. Thank you for joining us. I just took us on a deep dive into Web3. Understand? Introduction to Web3. We all know what Web3 is now. So, ladies and gentlemen, if you have any questions, this is the time to ask them now.